Here's how you can use the periodic table to remember the typical order that uh, subshells are filled or orbitals are filled in an atom. You start with 1s, and then 2s, then 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, and then 7f, and then 5d, and then 6p, 7s, and then it will be 5f, then followed by 6d, and then 7p. Okay? Alright, so one thing you'll note about this is that if you look at this block right here, which we call the P block, this is the right side of your periodic table. If you count the number of columns here, there are 6 columns here. This is columns 13 through 18. Okay, and if you remember, the most number of electrons that you can put in a p subshell is 6. For each p orbital, you can put 2, but p orbitals come in sets of 3. So you can have as much as 6 electrons in a p subshell. And so that's a good way to remember. There's 6 columns on that part of your periodic table. If you look at this block right here, there's 2 columns right here. You call this the S block. Okay, this is the P block, by the way. That's the P block. That part of your periodic table is called the P block. This part of your periodic table right here is called the S block. Okay, you'll notice it's 2 columns. Okay, over here in the middle, if you count the number of columns here, look at this. This is from column 3 to column 12. That's 10 columns. Okay, a good way to remember that this is the D block is that in a D subshell, you can put as much as 10 electrons. Okay, and for an S block, then the most number of electrons you can put in an S subshell is 2. So a good way to remember that these 2 columns here represent the S block. Is the most you can put in an S subshell would be 2 electrons. And if you look at this one, you'll notice that this F block consists of 14 columns. The most number of electrons you can put in an F subshell is 14. Okay. So let's look at an example here. What's the electron configuration for scandium? The way you would do this is you'd say, okay, it's 1s2. Okay, the first 2 electrons will go in the lowest possible energy orbitals. That would be the 1s. Then the next electrons will go to the 2s or 2s subshell, and you can put 2 electrons there. And then the next one would be 2p. That allows you to put 6 electrons there. So that takes care of 10 electrons so far. 2 plus 2 plus 6, that's 10 electrons. Okay, how many more electrons do we have to fill in to account for? So yeah, you're dealing here with 10 electrons so far. And scandium has 21 electrons. So you get 11 electrons more to go. So the next subshell that can hold electrons would be 3s. You put 2 electrons there. That makes 12. And then 3p, the most you can put in a p subshell is 6. So that takes care of another 8 electrons, or up to 18. Up after 3p, you put the next 2 electrons in the 4s. That gives you 2 more electrons. So that's 10 plus 8 plus 2. That's 20 electrons. Then the next electron will go in the 3d subshell, so 3d1. So your electron configuration is this: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. That accounts for the 21 electrons of scandium.